Hey guys, so I'm going to show you why this sophism is wrong. So to start with, we are given two different methods to find the volume of the solid of the hyperbola, y squared equals x squared minus 1, when it is rotated around the x-axis on the interval -2 to 2. The first method we are given is to take the antiderivative of y squared of f of x squared times pi to find the volume of the solid of rotation. When we solve for the interval -2 to 2, we end up with 4 pi over 3 units cubed. The second method we are given involves finding half of the volume of the solid and then multiplying that by 2. To quote the problem, since the hyperbola is symmetric about the y-axis, we can find the volume of a half of the solid of revolution and multiply by 2. Obviously the point 1, 0 is the vertex to the right of the origin, and the right range of the hyperbola is to the right of the vertex. Therefore, the volume of the right half is volume 1 equals pi times the antiderivative of f of x squared on the interval 1 to 2, which equals pi times 1/3 x cubed minus x on the interval 1 to 2, which gives us 4 pi over 3 units cubed. However, to get the full volume, we need to multiply that by 2, and we end up with 8 pi over 3 units cubed. This poses a problem because it appears to prove that 4 pi over 3 equals 8 pi over 3. Or, in other words, 1 equals 2. So now we're going to take a closer look at the second method, which gives us the equation 1/2 volume, or V1, equals pi times the antiderivative of f of x squared on the interval 1 to 2. Let's graph the equation and its solid. Alright, so finding the volume from 1 to 2 gives us the volume of from here to here. Or in other words, this area right here. Instead, we want to find the volume of the solid on this part. Thus, we need to change the interval for this equation. To find the volume of the right half, we should use the equation pi times the antiderivative of f of x squared on the interval from 0 to 2. To get the entire volume of the solid, we need to add V2, which would equal pi times f of x squared on the interval -2 to 0. So we end up with pi times 1/3 x cubed minus x on the interval 0 to 2 plus pi times 1/3 x cubed minus x on the interval -2 to 0, which gives us and as an end result, we get 4 pi over 3, which equals the same thing that we got in part A.